Tolerance stack-up analysis is vital to mechanical fit and function. With TolAnalyst, these tasks can be completed directly on your models inside of SolidWorks Premium. TolAnalyst is a tolerance analysis tool used to study the effects that tolerances and assembly methods have on dimensional stack-up between components of an assembly. For instance, in this sheeter, it is critical that the knife assembly maintains a certain gap between the blades to maintain proper cutting performance. There are several components of this assembly which contribute to this gap, such as the blades, the holders, and the bushings and pins. TolAnalyst leverages product and manufacturing information, or PMI, which is created on the parts with the DIM Expert tool. To minimize stack-up, we will control the location of the holes from the blade mounting surface, or datum A, and choose a press-fit tolerance for the bushing bore. In the assembly, a TolAnalyst study walks you through a 4-step procedure. First, we identify a measurement that we want to analyze. In this case, the gap between the upper and lower blades. Next, we identify an assembly sequence. The lower blade holder will be assembled first, then the lower blade, the guide pins, the bushings, and the upper blade holder. Then, finally, the upper blade. Next, we define how each part is placed or constrained in the assembly. Here, TolAnalyst is leveraging the PMI from DIM Expert. For the blade, there are 2 placement constraints available, but since we're only concerned with the constraint in the X direction, we'll choose that one. Next, the guide pins get constrained to the holes in the lower blade block, and the inside diameter of the bushing to the guide pins. The upper knife block can be constrained to the guide pin OD, ID, or the pin OD. We'll choose to constrain the outside diameter of the bushings to the upper knife block to simulate the press fit. And finally, we'll constrain the blade to the upper knife block. In the analysis results, we are presented with the nominal measurement, the worst-case minimum and maximum, as well as the RSS, or root sum squared, min and max. For this example, to maintain proper cutting performance, we need the gap to be between 0 and 0.25 millimeters. The contributor list states each contributing feature and its percentage contribution on the worst-case minimum or maximum. When you select an item in the list, the dimension or tolerance appears in the graphics area. Double-click an item to access the dimension tolerance or geometric tolerance dialog box, where you can modify the tolerance values in the part. Here, we will change the position tolerance, locating the hole in the lower knife block, and click Recalculate to compute new results. We still don't meet our desired result of between 0 and 0.25 millimeter gap. The upper knife block is now the highest contributing feature. Let's tighten up the position tolerance on this one as well and recalculate. We now meet our desired goal. But what if we consider the float in the guide pins? These close running fits add a bit to the calculated gap, but we are still within our results, and we can see their contribution to the worst-case minimum or maximum conditions. Finally, these results can be exported to an Excel spreadsheet to document the tolerance stack-up. This includes the analysis parameters, the measurement results, and the tolerance information for each of the features. TolAnalyst is an essential tool to ensure that the components of your assembly always fit together and meet mechanical performance requirements. SolidWorks applications provide great capabilities you can use right away for design, simulation, communication, and file management to work faster and make your products better. Explore all the features in the demo library or contact your nearest SolidWorks reseller.